In the last video, we have discussed about friction, and here we are going to discuss some examples to make that more clear. So we have first example here. Determine the maximum acceleration of the train in which a box lying on its floor will remain stationary. And here we have coefficient of static friction between these two surfaces, between the surface of the box and the surface of the train, which are in contact. This is given as mu s equals to 0.15. Okay, so we have to find the maximum acceleration of this train. So what is happening here? This box is lying on the floor of the train, and if this train accelerates, this box will also get acceleration with the same amount unless it starts sliding over the surface. So up to a certain limit, it will continue accelerating with the acceleration of train, and we have to find out that maximum acceleration, because beyond that, uh, if acceleration is beyond that, that is force on this block is beyond a certain limit, that is limiting friction, then this block will start sliding. So we have to find out this maximum force. Eventually, this maximum force will provide the maximum acceleration here. So this maximum force is nothing but friction here, static friction, maximum static friction. So we can write here mass into maximum acceleration, which can be produced in this box. Of course, this will be produced by accelerating this train. So eventually, we are going to get the maximum acceleration of this train. This one will be mu s into n. So we have uh, a max, maximum acceleration, equals to mu s, which is 0.15, and n, which is, look, what is n here? Normal reaction here. So if there is no vertical acceleration in this block, this normal force should be equal to its weight, that is mg. So here we will have g only, because m we have cancelled out from here. So this will be, a max will be nothing but 0.15 g meter per second. And if we are taking g equals to 10, then we will get some value here, or we can take 9.8 or 10. So based on the value taken for the g, then we will get here numerical value of this maximum acceleration. So this is one thing. Okay, now moving to the next problem, and let's see what is happening here. A mass of 4 kg rests on a horizontal plane. So here a mass of 4 kg rests on a horizontal plane, and the plane is gradually inclined until an angle theta equals to 15 degree with the horizontal. The mass just begins to slide. And the second case, it is represented here by this diagram. Okay, so we have a block, and this block, initially it was kept on horizontal surface, and then we started making some angle with horizontal with this. This horizontal surface was inclined to a certain angle, and at that angle it just starts to begin. That is, at this certain angle, whatever is given here, this is theta equals to 15 degree. Okay, so at this certain angle, theta equals to 15 degree, what is happening? It just starts to slide. That is, this force is equal to the limiting value of static friction. So F max equals to mg sine theta. Okay, let me make it clear how these forces are being represented here. So look, this is mass, let's say, free body diagram we are just making here, and there is one force vertically downward, which is its weight. But what do we need here? Here we need the component of this force along the inclined plane, as well as the component of this force perpendicular to the inclined plane. So this mg has been resolved, this mg has been resolved into its components. One component is along the inclined plane, and this component, which is mg sine theta, you can see here. We have done the vector resolution concept in previous video, so I'm just using it here. So mg sine theta is the component along the inclined plane, and this mg sine theta is responsible to overcome the maximum static friction here, or limiting value of the static friction, and this thing can be written as Fs max equals to mg sine theta. Okay, now this Fs max will be mu s into n. Yes, we know about it. The limiting value of static friction is mu s into normal. Okay, what is the value of n? If there is no acceleration along this direction, that is perpendicular to this inclined plane, if there is no acceleration, then this normal should be equal to mg cos theta. So here n can be replaced by mg cos theta. This is nothing but Fs max mg cos theta, and if we are multiplying this thing by mu s, this is Fs max, which is equal to mg sine theta. So ultimately we have mu s equals to sine theta by cos theta equals to tan theta, and then we can find out the value of tan 15 degree. As theta we know from the question, it is 15 degree, so we can find out the value of tan 15 degree, and that will be the coefficient of static friction between the block and the surface. Okay, now moving to the next question. Here we have another one. So what is the acceleration of the block and trolley system shown in the figure if the coefficient of kinetic friction between the trolley and the surface is 0.04? Okay, this thing Fk we can find out mu k into n. And what is n here? N is nothing but the, it will be equal to the weight of this block, which is 20 into 10 Newton. So S weight equals to mg, which is 20 kg into 10 meter per square second. So ultimately this will be in Newton, that is 200 Newton. So weight is 200 Newton here, and this weight is equal to the normal force, because there is no acceleration in vertical direction here. So this will be 200 Newton. So we have Fk equals to mu k. Mu k is given here, which is 0.04 into 200 Newton. So this will be, I think this will be 10108. Okay, this will be 8 Newton. So one thing we have here, that is kinetic friction. Now second thing here, what will be the tension? Okay, we are not going to get exactly tension right now, but yeah, we will get some equations, and after solving those equations, we can get the tension as well as acceleration of this system. So what is happening? Let's say this small weight is accelerating downward. Let's say this acceleration is a, and if this acceleration is a, then this 20 kg block will also accelerate with the same acceleration. So whatever be the acceleration, it will be transferred to this block also, and these two blocks will accelerate with the same acceleration. So we can write Newton's law of motion for these two blocks here. So let me make it clear and write only Fk somewhere, and then we can go on. Okay, so okay, we had Fk equals to 8 Newton, and acceleration, let's say this is a, and the downward acceleration here is a. So for this block, P minus Fk, this is the net force because let's say this is accelerating along t, so t will be greater. So P minus Fk will be mass times acceleration. This is net force on this block. Then it should be equal to mass times acceleration, that is 20 into A. Okay, here every thing is expressed in SI units, so I'm not writing all those units, but at the end we will get the results in SI unit only. So for this block, we are getting this equation, and we have this Fk is 8. So 20A. Okay. Now, second thing, for this block, this is accelerating downward. So 30 Newton minus this tension. This is the net force on this block, and it should be equal to mass into acceleration, that is 3A. Now we have two equations, this one and this one. And we have two variables also, unknowns actually. One is tension, another is acceleration. So with these two equations, we can find out these two unknowns also. Let's rewrite this thing. T minus 8 equals to 20A, and 30 minus T equals to this equals to 3A. So this is 3A. Now we can add these two things, these two equations, and then on left hand side we will get T minus 8 and plus 30 and minus T. So plus T minus T will be cancelled out, and this will be 22. And right hand side, here this should be 20A, and right hand side there is 23A. So acceleration will be 22 by 23, and it should be in SI system, so meter per square second. And if we know the acceleration, we can use any of these two equations to find out the tension. So let's say from here, tension will be 30 minus this 3A. Here, from here, tension will be 30 minus 3A. So 3 into 22 by 23. So T equals to whatever be this value, we can express the same thing in Newton. So this is the value of tension here. Okay, this is all for now. In next video, we are going to discuss rolling friction, and then we can discuss motion of bodies on circular paths.